Hi everyone and welcome back to activity 34. Today we are going to talk about the inverse of a matrix. Now, what an inverse of a matrix is going to exist if and only if the matrix is what we call non-singular. Well, what does that mean in our terminology? Basically that it's a square matrix, so a 2 by 2, 3 by 3, 4 by 4, etc., that has a determinant not equal to 0. So essentially each time if an inverse is going to exist, you want to ask yourself two questions. First of all, is it a square matrix? So your rows and your columns match each other. N equals N kind of deal, they're the same. And you want to determine, is the determinant not equal to 0, basically. Okay, if it's no, to either of those, then your inverse does not exist. Okay, now you might be asking, okay, I know what a square matrix is, but what the heck is this determinant thing? Like, what is that? Well, a determinant of a matrix, you will either see represented by absolute value bars around your matrix, or sometimes you see it called DET times your matrix. But basically, a determinant can be found different ways depending on the size. But basically, they're only going to occur in a square matrix. And in particular, so again, a 2 by 2, a 3 by 3, etc. And for a 2 by 2, in order to find the determinant, you're going to find the difference of the products of the diagonals. So how that looks is here's our matrix, A, B, C, D are the entries, and we want to find the determinant of that. Or again, if you see absolute value bars, that means determinant. And basically what you're going to do is you're going to take your elements A and D, multiply them together, and then you're going to subtract away from it the product of B times C. And that'll find your determinant for you. So for this first one, we are going to take A times D, so 6 times 3, subtract away from it B times C, so 5 times 8. We end up with 18 minus 40, so we get negative 22. Or the second one, we end up with A times D, so 2 times 6, minus B times C, 3 times 4, okay, and that's 12 minus 12. Our determinant this time is 0. Okay, so it's always A times D first, minus B times C second. Try that third one on your own. Now, if it's a 3 by 3 matrix, our process is a little bit more intensive, because what you end up doing is rewriting columns 1 and 2, and then you take the diagonals, you multiply dot product, and then the other, going the other way, product, subtract those away to get your overall determinant. Now that's kind of a complicated process, so for the most part, we like to use our calculator. And in order to do that, step 1 is you have to type your matrix in. So for this first one, I'm going to type in, I'm going to go second matrix, I'm going to edit, so I'm going to type in, I'm just going to call this one matrix A. It is a 3 by 3. And I'm going to type in my entries. So 4, negative 2, 0. And then my second row is negative 3, 10, 1. And then my third, 2, 6, negative 1. And then I'm going to quit out after I edit it. And I'm going to go then back to my matrix menu, and I'm going to scroll over, and we notice option 1 is determinant. And then we go back in and select the matrix we're trying to find the determinant of. And we see this time we get negative 62 as that determinant. Okay, so using our calculator to check. So again, step 1, enter the matrix. Step 2, go to matrix, menu, then math, and select option 1, DET, and then enter. Again, that matrix in. All right, now we want to decide from there, once we know how to find a determinant, if our inverse itself is going to exist. So in this case, if we look, okay, we have A times D, 3 times 1, minus B times C, 4 times 2. We end up with 3 minus 8, so negative 5. The answer here is going to be a yes. Okay, we have a square matrix. The determinant does not equal 0. So this matrix is going, or this matrix will have an inverse. Next one, if we do B times C, 2 times negative 3, minus B times C, negative 6 times 1, we end up with negative 6 plus 6, right? Minus negative 6 times 1, that's 0. This one is going to be a no because the determinant does equal 0, and so our inverse is not going to exist. Okay, on this next one, number 7, okay, again, this is a good time to review typing in. I'm going to call this one matrix B, but we have another 3 by 3 matrix. This time, my entries are negative 4, negative 6, 2, 5, negative 1, 3, and then negative 2, 4, negative 3. And again, if I'm going to find the inverse then of this, I'm going to go back under my matrix menu, select determinant, and then matrix B. I get 18 is the value of the determinant. So this one is in fact going to have an inverse because again, that determinant is not equal to 0. So we know it'll exist. All right, try that last one on your own. What's the determinant? Does it work? All right, now if our determinant is going to cause our matrix to not exist, this is where we want to actually calculate then the value when it would equal 0. So we would have 4 times x, and then minus b times c, which is 2 times 8. When will it not exist? Well, when it equals 0. So we set up and solve. 4x minus 16 equals 0. 4x, if we add over 16, equals 16. So when x equals 4, this would cause us an issue. Try the other one on your own. All right, now, if we find out our matrix does in fact, our inverse does exist for our matrix, okay? Well, then your value of your inverse to actually find that, you're going to take 1 over the determinant value, and then to actually get the inverse, you are going to flip A and D's location, and then you're going to just change the signs of B and C to get that value. Now, what the heck is a matrix purpose? Well, basically what's going to end up happening is each time that you have a matrix times itself, it's almost like it undoes it and it creates, when they multiply, the identity matrix. So for instance, a 2 by 2, the resulting product would be this. Or a 3 by 3 we talked about, it's basically when these 1s are all along the diagonals. So that's how you know something is an inverse, is when you multiply, you get these identity matrix. All right, so again, we want to actually be able to find like what the heck the inverse of the matrix is. Does it actually exist? What is it? So for this first one, A times D minus B times C, we end up with 8 plus 12 for a total determinant value of 20. So yes, this inverse is going to exist. And what we're going to do then is we're going to take 1 over 20, the value of the determinant, so 1 over that, and then we're going to switch. A and D switch spots. 2 and 4 now switch spots. B and C are now going to switch signs. So negative 3 becomes positive 3, positive 4 becomes negative 4. And then you just distribute that scalar to each piece. So we have 4 over 20, 3 over 20, negative 4 over 20, and then 2 over 20, which many of these can reduce. 4 over 20 is the same thing as saying 1 over 5. 3 over 20 does not simplify. Negative 4 over 20 is negative 1/5. And then we have 1/10. And again, if you ever are unsure, like does negative 4 over 20 simplify? Math, enter, enter. Boom, you see that simplifying. On the second one, if we look at this example, again, start by finding the determinant. 8 times negative 1 minus 9 times 3. We end up with negative 8 minus 27. So negative 35 is our determinant. That's not 0. So this is going to work out to have an inverse, and we put that out front. And then to get our determinant, we take A and D, they switch spots. B and C flip signs, so positive becomes negative for both of those. And again, we distribute that negative 1 over 35 through. So in this case, our result ends up being a positive, because a negative times negative is a positive. And then again, another positive, because those negatives cancel out. And then the negatives cancel out one more time. And then our last one. And none of these reduce. So that'll be our final. All right, next one, if we go to start solving, A times D minus B times C, we end up with negative 6 plus 6, which is 0. Well, because our determinant equals 0, our inverse is not going to exist. Try number 4 on your own. Get that value of their determinant if it exists, or inverse if it exists. All right, last but not least, 5 and 6, when it comes to the inverse, okay, we want to find this in our calculator. So again, we have matrix B actually already entered, or matrix A, excuse me, already entered from our previous questions on this page. So I'm going to select that. And then to be able to type this in your calculator, you would just take, select the matrix and then get your inverse. Okay, now that looks craziness, but we can just do math, enter, enter to get this back to a fractional value as our final answer. Okay, so these 3 by 3s we do not want to necessarily do by hand. What we are going to do instead is just use our technology, use our calculators to be able to solve that. So for this last one, you are going to want to solve B in your calc yourself. Thanks everyone for watching. We will work more with these in class.